Every single day. You walk around your house, right?
Hey.
You plug in your phone charger, you turn on a lamp, or, start the coffee maker.
Yeah, it's completely on autopilot. We don't even think about it.
Exactly. You look at that little plastic face on the wall.
The one with the two vertical eyes and the surprised little mouth.
Yes, that exact one. And you feel total confidence, right? You just push the metal prongs in and your device comes to life. It feels completely routine.
Totally routine.
But today, we are going behind that cheap plastic plate. Because, well, there is a constant, invisible, high-stakes drama unfolding, literally millimeters away from your fingers.
Oh, absolutely. It's a drama most people are completely unaware of.
Right. And this deep dive is guided by just a fascinating essay called 3 Wires in the Wall. It's by Lev Nemotin, an engineer and PhD.
It's a brilliant piece of writing. Really changes your perspective.
It really does. So our mission today is to completely rewrite how you understand the electricity in your home based on his work. We are going to strip away, all the dense engineering jargon.
Which is much needed, honestly.
Definitely. And more importantly, we are explicitly banning those lazy metaphors people always use to explain this stuff. You know the ones.
Oh, the water pipes.
Yes. Where someone tells you electricity is just like water flowing through a pipe, and a switch is a safety valve. We are not doing the water pipe thing today.
Which is great because the water metaphor actually limits your understanding of what electrons are really doing inside those walls. Electricity is not water.
No, it's not. So we are sticking strictly to the vivid and frankly slightly terrifying imagery that Nemotin provides.
It's a much more accurate physical reality, and it's so much more interesting.
It really is. So I want to start by throwing out the names we all use. If you've ever seen a receptacle pulled out of the wall, you know there's a black wire, a white wire, and a bare copper wire.
Right, the classic trio.
Yeah, and you probably know them as hot, neutral, and ground. I mean, when I learned those names, I felt like I understood how to wire a room.
It gives you a false sense of security, doesn't it?
A completely false sense of security. Reading this essay, I realized those names trick us.
They do because those labels trick us into assigning personalities to the wires.
Exactly. We hear hot, and we assume that's the aggressive, angry wire.
Right, the bad guy.
Yeah.
And we hear neutral, and we assume it's passive, just hanging out, not bothering anybody.
Yeah, I always pictured the neutral wire sitting on a park bench, sipping tea, while the hot wire did all the heavy lifting.
Right, and then ground sounds like some sort of benevolent protector, like Mother Nature herself is in the wall keeping you safe.
Which is just not true.
Yeah.
Wires don't have personalities. And they definitely don't have morals. They only have jobs.
Yes. And to understand those jobs, we have to realize this whole system is really just a story about paths.
On paths, right.
The path electricity is meant to take when everything functions properly, the path it takes to get back, and, crucially, the emergency path.
The one that keeps the electricity from traveling through you when something inevitably breaks. So, if we are ditching the idea that the black wire, the hot wire, is just angry, how should we actually picture what it's doing when you plug something in?
Well, Nemotin uses this specific, really vivid phrase.
The electron vacuum cleaner. I love that so much.
It's brilliant, right? It's a very visceral way to describe it.
It really shifts your perspective. Instead of seeing electricity as a substance flowing out of the wall, you see it as an appetite, an electrical appetite.
That's exactly it. Because the black wire is connected all the way back through your breaker panel, out to the transformer on your street, and ultimately back to a power station.
So it brings this immense electrical pressure right to the edge of your living room.
Yes. But it doesn't want to attack you. It's just an appetite. It just wants a path.
Wait, let me make sure I'm wrapping my head around this pressure concept.
Yeah.
Because Nemotin mentions we are dealing with alternating current, or AC.
Right.
So if it's alternating, the electrons aren't actually being sucked from my wall, traveling through my lamp, and going miles down the road to the power plant, right? They aren't going on a long road trip.
That's right. They aren't traveling like cars on a highway. In North America, our alternating current operates at 60 hertz.
Okay, so what does 60 hertz actually look like in the wire?
It means the electrical pressure is pushing and pulling 60 times every single second.
Oh, wow.
Yeah, the electrons in the wire aren't migrating long distances at all. They are violently vibrating back and forth.
Violently vibrating.
Right.
So the vacuum cleaner metaphor still works perfectly, though, because it describes the power to recruit.
Exactly, the power to recruit. The electrons are already sitting there in the metal of your lamp's wire.
The black wire just provides the massive pressure required to violently organize them into motion.
Precisely. It recruits them. So the appetite doesn't care what you put in front of it at all.
Right, if I give it the tiny tungsten filament of a light bulb, it pushes and pulls through that. It creates friction, which creates light.
And if you give it the heating element of a space heater, it makes heat. It's totally indifferent.
Indifferent. I think that's the key word here.
It is. The power grid has an almost incomprehensible amount of energy, and the black wire is the gateway. But here is the catch.
A vacuum cleaner is completely useless on its own.
Right. It cannot do any work if it only has one way in. A single black wire is basically half a sentence.
Because if it's pushing and pulling, the energy needs a closed loop to actually move through. There has to be a return path to complete the circuit.
Precisely. The electricity must have a way back to the source to complete that whole push-pull cycle.
Enter the white wire, the neutral.
The neutral.
And this is where my mind was completely blown, honestly, because of that deceptive name. Neutral makes it sound safe.
It really does. But Nemotin calls it the quieter partner in the circuit.
Which implies it's still very much a partner.
Oh, it absolutely is. It is the necessary return road. If you take away the white wire, the circuit is broken and your device does absolutely nothing.
So why is it called neutral?
Well, the problem is that neutral is an engineering term that got misunderstood by the public. In technical terms, it means the white wire is tied to the grounded reference of the whole system back at your breaker panel.
Okay, wait, stop right there. Grounded reference. What does that actually mean mechanically? Are we talking literal dirt?
We are talking literal dirt.
Seriously?
Yes. Back at your main electrical panel, the neutral system is physically connected to a heavy copper rod driven deep into the earth outside your house. Or sometimes it's clamped to your metal water mains.
Wow. Okay.
So relative to the dirt you are standing on, the white wire has a voltage of 0. That's why engineers call it neutral. It shares the same voltage level as the earth.
But just because it has a voltage of 0 relative to the dirt doesn't mean it's safe to touch when a device is running.
Absolutely not. And this is a crucial misconception.
Yeah.
When your lamp is turned on, the vacuum cleaner is pushing and pulling through the black wire, through the light bulb, and coming back through the white wire.
So the white wire is actively carrying all of that working current.
Yes. It is an active participant in that violent movement of electrons.
You know, I actually have a slightly embarrassing story about this.
Oh, really? Let's hear it.
A few years ago, I was replacing a ceiling light fixture. I flipped the light switch off so the light was out.
Oh, no. I know where this is going.
Yeah. I assumed the power was gone. I touched the black wire. Nothing. Totally fine. Then I went to untwist the white wires, and I got a nasty shock.
Ouch.
Yeah, it turned out the white wire was being shared by another circuit in the house that was still running. It felt anything but neutral.
That is a classic and, frankly, very dangerous DIY mistake. You assumed the white wire was just passive infrastructure.
Right, like a piece of structural framing in the wall or something.
But it is an active highway. When a circuit is live and under load, the neutral is fully in the game.
So, okay, if the black wire is this massive, dangerous appetite, and the white wire is an equally dangerous return road, how is it that we don't think twice about grabbing a cheap table lamp to turn it off?
Well, Nemotin uses this great phrase, the private storm, to describe what happens inside our appliances.
The private storm. I think it's one of the most powerful images in his entire essay.
It really is, because when you look at a table lamp, you see the metal base, the fabric shade, the plastic knob. It looks totally innocent.
But the electricity inside that lamp hasn't learned good manners.
Not at all. It is just as wild and capable of harm as it is in the high voltage lines down the street.
It didn't take an etiquette class before entering the bedroom.
No, it didn't. The reason you don't feel it is because that wildness is strictly confined. Inside the lamp, the manufacturer has built an assigned tunnel.
Like the thick plastic insulation wrapping the copper.
Exactly. The metal connections are physically isolated from the outer shell you touch. When you click that switch, you are inviting the electron vacuum cleaner to roar to life.
It's pushing and pulling through that specific tunnel.
Yes. You are literally holding a private electrical storm inside a piece of furniture.
A private storm. That just really reframes it for me. A safe device, as Nemotin writes, is basically a small agreement between usefulness and danger.
That's beautifully put. We get the light, but only as long as the storm stays in the tunnel.
Right. And that agreement holds up most of the time. The black wire brings the appetite, the white wire provides the clean return path, and the insulation keeps the storm away from your hands. But if those two wires are all we need for the happy path for the lamp to shine and the loop to close, Why do we need the third wire?
The bare copper one. Or sometimes it's wrapped in green. The ground.
Yes. Why is it even there?
Because the story has to shift from everyday operation to emergency preparedness. And Namotin gives the ground wire two incredible titles.
The unemployed bodyguard and the humility wire.
Yes.
The unemployed bodyguard. I mean, we've all plugged in devices that only have two prongs, right? Like my phone charger doesn't have a third prong.
Sure, you don't technically need the ground wire for a circuit to function.
You don't.
Right. On an ordinary Tuesday, when everything's working perfectly, the ground wire carries zero current. It does absolutely nothing.
It just sits in the wall, completely unemployed, waiting.
It exists purely for the day the happy path fails.
So walk me through the mechanics of a failure. Let's imagine a heavy metal appliance, like an old washing machine maybe, vibrating away in a damp basement.
Okay, let's use the washing machine. In a perfect world, the black and white wires stay inside their assigned tunnels.
Right.
But life isn't an engineering diagram. Things age. A washing machine vibrates thousands of times a week.
Over years and years.
Over years, the internal wires rub against sharp metal edges inside the casing. The plastic insulation dries out, it gets brittle, and it cracks.
The tunnel breaks down.
The tunnel breaks down. Now, imagine a tiny flake of insulation falls off the hot wire, and the bare copper of that black wire physically touches the inside of the metal washing machine case.
Oh, so the vacuum cleaner is out.
The vacuum cleaner has breached the tunnel, and this is where the unseen drama gets terrifying.
Because the washing machine doesn't spark right.
No, it doesn't spark, it doesn't smoke, it doesn't glow red to warn you.
It looks exactly like the same appliance you've used for a decade.
But its entire metal shell is now electrically hot. The private storm has expanded to the surface. As Namotin puts it, the machine is now wearing the costume of a safe appliance.
Wearing the costume of a safe appliance. That is genuinely chilling.
It is.
So the storm is no longer contained. It's just sitting there on the metal waiting. And if you have an older house with no ground wire, what actually happens when you walk up to it?
The machine waits for you to become the rest of the circuit.
Wow. This is the part of the essay that makes you rethink human biology. Because Namotin says if you touch that broken machine, you become the white wire.
Yes, you become the return path.
That's terrifying.
And human biology is exceptionally vulnerable to being used as a return path. We think of ourselves as solid objects, but electrically speaking, we are just bags of wet chemistry.
Bags of wet chemistry.
Think about it. Your sweat has salt in it. Your blood has electrolytes. Your nervous system, your brain, your heart beating, they all rely on microscopic, delicate electrical signals.
Wet chemistry. So when a massive household electrical circuit with all that grid pressure behind it recruits your wet chemistry.
It completely overrides your body's internal signals. The electrical appetite doesn't know the difference between a copper wire chosen by an engineer and a human hand chosen by accident.
It's totally indifferent.
Exactly. It just sees that a path to the earth has finally opened up. Your feet are on the concrete basement floor, your hand is on the metal machine, and the electricity takes the path right through your chest.
Unbelievable. Which brings us to the actual hero of this setup. The humility wire. The ground.
Yes.
How does this unemployed bare copper wire stop me from becoming the return path? Is it like kind of like a runaway truck ramp on a steep mountain highway?
That's actually a great way to picture it.
Like the current loses its brakes, so we build this ultra-smooth straight ramp that intentionally catches it and gets it off the road.
It is exactly like that, but with a mechanical twist. Because the ramp doesn't just catch the runaway truck. The act of the truck hitting the ramp is what sounds an alarm to shut down the entire highway.
Oh, interesting. How so?
Well, the ground wire is physically bolted to the inside of the washing machine's metal casing. It's always there, touching the metal.
Okay.
So the moment the black wire's insulation fails and touches the case, the escaped current immediately finds this bare copper path leading all the way back to your electrical panel.
And because it's copper, it's a much easier path than my damp basement feet.
Significantly easier. In physics, we talk about electrical resistance. The human body has relatively high electrical resistance compared to metal.
Right.
Copper has almost zero resistance. So when the pressure hits the metal case, it doesn't wait around. An absolutely massive, violent rush of electrons takes the copper path.
The runaway truck hits the ramp.
Exactly. It creates what we call a short circuit, and here's how it actually saves you, mechanically.
I'm listening.
When that massive, unimpeded rush of current travels back to your breaker panel, it passes through the circuit breaker. Inside that breaker is a tiny coil of wire.
Okay.
When a huge amount of electricity flows through a coil, it creates an electromagnet.
Oh, so it's not a computer chip making a decision,
Yeah.
it's physics.
It is raw physics. The short circuit creates such a powerful magnetic force inside the breaker that it physically yanks a piece of metal, snapping the switch to the O-off position in milliseconds.
The power is severed before you even walk into the room.
Exactly.
That is incredible. The ground wire doesn't just absorb the shock, it deliberately causes such an extreme surge in current that it forces the mechanical safety switch to trip.
It literally destroys the circuit to save the user.
Wow. And that is exactly why Nemotin calls it the built-in humility wire.
Yes, it is the engineer admitting ahead of time that perfection is impossible.
Right, they're acknowledging that plastic insulation will eventually crack.
Water will get into places it shouldn't. People will touch things without thinking. The ground wire is an admission of failure.
On its best day, it does absolutely nothing. But on its worst day, doing nothing transforms into doing the only thing that matters.
It gives the electricity a better deal than your body and keeps you off the map.
Man, I don't think I can look at a wall outlet the same way again.
Good. You shouldn't.
So let's tie this all together for everyone listening. Let's decode that little plastic face on the wall based on the actual mechanics we just went through.
It's quite elegant when you know how to read it. The physical plastic face is telling you the exact story of the three wires.
So you have the two vertical slots, and if you look closely, one is slightly narrower than the other.
The narrow slot is the hot, the black wire. That is the dangerous invitation.
The dangerous invitation.
Yes, that is where the electron vacuum cleaner sits, waiting with immense pressure to recruit a path.
And then the wider vertical slot next to it.
The wider slot is the neutral, the white wire, the return road.
The quieter partner that shares a reference with the Earth.
Exactly, but it's the essential second half of the sentence required to complete the push and pull of the circuit.
And finally, that round hole sitting below them.
The emergency exit, the bare copper ground, the unemployed bodyguard waiting for the inevitable day when the storm escapes its tunnel.
It really is a three-act play molded into 50 cents worth of plastic.
It really is.
You've got the appetite, the normal return, and the emergency override. And I think the biggest paradigm shift from Nemotin's essay is how we view our relationship with nature.
How do you mean?
Well, the electrical system in our houses does not make electricity harmless. We don't possess the technology to make 120 volts of alternating current harmless to human biology.
No, we definitely don't.
What this system does is make electricity behave.
That's a vital distinction. We make it behave by engineering better, more attractive paths than our own bodies. We are managing an unstoppable force of nature, not neutralizing it.
We've just managed to trick a tiny piece of that storm into staying inside the walls, running through its assigned tunnels, doing our chores, and ignoring the wet chemistry of our hands.
It's quite an achievement when you think about it.
It is. But before we wrap up today, I want to leave you, the listener, with a final thought to chew on. Something that goes beyond just understanding the wires in your wall today.
What's on your mind?
Well, think about the fact that this specific three-wire system, this exact physical interface we just decoded, was designed almost a century ago.
Right.
Back then, it was meant to power some incandescent light bulbs, maybe a radio, eventually a refrigerator.
Very low demands compared to today.
Exactly. Today, we are using that exact same legacy grid to charge massive lithium-ion batteries in electric vehicles, to power whole home computing systems, and to pull loads of energy that the original engineers couldn't have even imagined.
It's true. The load is staggering now.
As we push the vacuum cleaner to draw more and more power to feed modern life, I have to wonder how long this mid-20th century physical plug will survive.
That's a profound question.
Will we eventually move to wireless ambient power? Or will we just keep building thicker copper tunnels, trusting a 100-year-old plastic face to keep the storm at bay?
We really do rely on the physical integrity of those aging tunnels more than ever before.
We do. So the next time you plug a device into the wall, take a second to respect the appetite waiting just millimeters away. Keep your body off the map.
Understand the paths.
And remember the silent drama happening right behind the drywall.